review some transformations together. A rotation 90 degrees counterclockwise. Counterclockwise, 90 degrees looks like this. What's our coordinate rule for that? Opposite of y, x. So I'm going to go ahead and write down each one of these coordinates and then apply the rule. So I've got u, j, p, and e. I hate when they make them random like that. Guys, help me out with these coordinates. What's u?
0.
Thank you. What's j? 4, negative 4. Awesome. And p? 2, negative 3. And e? 1, negative 2. Okay, I'm going to apply my transformation. So I'm going to get u prime, j prime, p prime, e prime. What would u prime be? 0, 5, right? They switch places and the y becomes the opposite. But we apply the opposite before we move it, right? So j would be what? Make y opposite, which would be 4, and put it in front. So 4, 4, and what would p be? 3, 2. Wouldn't 4 still be what? No, you put the negative 4 becomes positive 4, and you put it in front, and the x becomes 4. It's not negative, it says opposite. So if it was negative, it's now going to be positive. Yes. Make sense? It's not negative y, it's the opposite of y. Okay? Make sense? Okay. E, what's e going to be? It's now negative, so it's going to be positive 2, comma what? Positive 2, comma what? No, no, no. The 1, it just switches. 1. See it? So u's at 0, 5. 1, 2, 3, 4, 5. That's kind of confusing because I've got all this up here. I'm going to fix this. You're going to say we're going to do a 90-degree turn, and then this is opposite of y, comma, x. Zero, 5, 2, 3, 4, 1, 2, 3, 4, 4, 4, 1, 2, 3, 2, and 2, 1. Does that make sense? Did we do that correctly? Okay, so 7 says it'd be easier to use patty paper. How could I rotate it using patty paper? Well, some people do. But you've got to rotate it from the center or the origin, correct? So wouldn't I just draw a line from E to the origin? Is that what you did, 7? You draw a line from here to here, and then you just rotate it 90 degrees. If you draw a line, you could draw a line and make a 90-degree angle from it. So I'm going to make a 90-degree angle. Check this out, guys. Do you see that? If I make a 90-degree angle, didn't it match up perfectly right there? Yeah. So that's another way to do it. If you'd rather use patty paper, because this is E prime right there. Fantastic. Let's rotate this one at 180. about the origin. I'm going to do this one a little bit differently. Let me use red this time. Check this out, guys. I need everybody to put your pencils down and look up here. I could either do it using the coordinate rule. What is the coordinate rule going in 180? The opposite of x, the opposite of y. Good. Or I could say, isn't it just straight across? If it's straight across, isn't that just right through the origin there? Right through the origin there? Right through the origin there? Now I just have to see how far over the origin. How far over the origin am I going this way? Well, if I had to go up 1 and over, is that 4? 1, 2, 3, 4. If I had to go up 1 over 4, I must have to go up 1, 1, 2, 3, 4. Did it match up? Here, up 2 over 3. Up 2 over 3. That one matches up there. This one, up 5 over 4. Up 5 over 4 matches up there. Which one do you think is easier? You like the coordinates better? You can use the coordinates. Let's do the coordinates. You like the visual? Well, this one, the rules, the coordinate rules? Okay, then use the coordinate rules. Okay, so help me out with the coordinate rules. It would be, this is JRP, JRP. What's J? What's the coordinates of J? -4, -1. What are the coordinates for R? -3, -2. What are the coordinates for P? -4, -5. I'm a visual person. I like it this way. But you can do it the other way as well. Whatever works for you. Alright, so J prime, R prime, P prime. What would J prime be? 4, 1. What would R prime be? 3, 2. What would P prime be? 4, 5. I want to show of hands. How many of you would rather just reflect it visually? Using this, just going straight across. Kind of like how 7 likes to rotate visually. How many of you like to rotate visually? Really? Yeah. Most of you would rather rotate using the rule? Yeah. That's what I mean, patty paper. Who would rather use patty paper to rotate? I'm trying to see if you like the visual, if you always like the visual, or if you like the visual sometimes and you like the rule sometimes. You like patty paper the whole time? Okay. Okay, this one says, number 3 says, a rotation 270 degrees clockwise. What would 270 clockwise be? $90 degrees counterclockwise. So don't worry about it. I would just cross that off and look at that. Because I know what that looks like, right? Instead of going this way, I just need to go this way, right? But since we're here, where am I going to end up? Okay, does everybody understand? Pretend there's no figure there. If it says to go clockwise, I would go like this to get my rule. But isn't going this way the same as going right there? Yeah. But I don't have a shape here that's going this way. It's this shape that's going to move from this quadrant to this quadrant. Do you understand what I'm trying to say? Hold on. I'm going to pause it, and I'm going to go up to the board and do it with my hand. Recording. All right, so let's go ahead. Now that we understand it's going to shift just one quadrant, right? It's going to shift one quadrant, or rotate. So apply the coordinate rule. N, Y, R. What's N? -1, 4. What's Y? -4, 2. What's R? -1, 0. Okay, let's apply the rule. What's my rule? What's my coordinate rule? What's my coordinate rule? Opposite Y, X. A 90-degree turn. Look at your rules on the board. What's a 90-degree rotation? If I went, wait, hold on a second. If you go 270 clockwise, that's the same as 90 counterclockwise. Because -x, -y is going 270 counterclockwise. If I say I'm going this way, 270 degrees, where am I at? If I go this way, right here, if I go this way, where do I end up? This is 0. What's this? How many degrees is this? 90. How many degrees is this? How many degrees is this? So if I decide I'm going to start going backwards, and I go backwards 270 degrees, where am I really at? If I go backwards on my graph, where did I end up? Okay, so now we're clear about our 90 and 270. Fantastic. Thank you for all of your help, guys. All right, rotating this 90 degrees clockwise about the origin. Okay, so a rotation of 90 degrees would mean that I've got to go what?
Down.
What's 90 clockwise? 270 counterclockwise.
Yeah.
You don't have to. So what's the rule? What's the coordinate rule to go all the way around? Opposite x. Y opposite x. That part you got to memorize.
What?
How do you know which is which? How do you know which is which? Because there's not really 4 of them. There's only 2. Watch, I'm going to do this again. I don't like that. Okay. You have to memorize. So this you don't have to memorize because that's already in your memory, right? X, Y. This one is the opposite. Since it's the opposite side, both of those coordinates are opposites. That's not hard to remember, right? Hold on. This one is the one you have to memorize, right? So instead of being x comma y, the y and the x switch, and the y becomes opposite. And you really don't have to memorize this one because it looks just like that one. The y and x switch, only this time the y isn't negative, the x becomes opposite. So do you see how I'm chunking those pieces of information so I don't have to memorize as much? Yeah? Better? one. All right, guys, we need to move on. Let's look at this one. Reflection across y equals -2. Where is -2 on the y-axis? Where would I go? Tell me where to move. Down. If I move down to, what's this coordinate? 0, -2. What's this coordinate? 1, -2. What's this coordinate? 2, -2. What's this coordinate? What's y always? -2. Right? So it's a horizontal line. Here's a really silly example. Remember Slope Dude, where it was undefined, right? Slope Dude? How many of you have seen Slope Dude? Not many of you. That's really sad. X, okay, so I look at it like this. If it's undefined, in a line like this, extreme sports, right? Go straight down like that. So X equals is an undefined line. Y equals is a horizon. Y, horizon. X, extreme sports. Just try to hold, right? Okay. But it's not a trick. I told you exactly the way it goes. Okay. So this will be a reflection over that line. So if Q is here, where's Q prime going to be? Across the line. If it's this way 3, it's going to be 3 more. If A is this way 2, it's going to be the opposite direction, 2. If X is 1 away, it's going to be in the opposite direction, 1. If N is 2 away from that line, it's going to be on the opposite side of that line. Yes, Giovanni? It told me across y equals -2. So I went down 2 and drew a line. Make sense? If it told me x equals 4, I'd go over 4 on x and draw a vertical line. All right. This one, translation 4 units down. All I got to do is move down, right? I'll just retrace my shape and move down. 1, 2, 3, 4. All right. What type of transformation is this one? Everybody look up. Stop looking down. Everybody look up. What type of transformation is this? Wow. You guys are good. If I reflected it, it would look like that. Is that the same shape? Oh, shoot. Is that the same shape? No. So it's a rotation. How much of a rotation did I have to go? Check this out, guys. Look. Look. You see my little thing up here? I'm going to go counterclockwise, right? Watch how far I have to move. Pretend like it's quadrant. So this is 90 degrees, right? 180. I did that wrong. I didn't do a full 90. Okay, so a full 90 would be here. You know what I'm doing is I'm not going around a proper circle. Oh, do you know what I'm doing? No, you have to count the first one, but look what I did. I reflected from here to here instead of here to here. Do you see it? Do you see how this one's got the prime? This is the pre-image. This is the image. So how much are we really going? Is it 90? Let's see. We're investigating, right? So if I turn it, how much did I turn it? I turned it 90, but I went clockwise, so it's 270 counterclockwise. Good, she got it. Yes, sir.
Also, using the counterclockwise, think of it how if you notice rotation, it ended up in a quadrant back, because on counterclockwise, you count the quadrant and multiply it by 90.
I like it. Did you guys hear it? You said count the quadrants that it moved and multiply them by 90. Yep. Good job. Good job. Good job. Okay, I need to show you one more thing before we go, so that you can finish your homework tonight. No, that is for you. We're going to do this one right here.
That's not on the tape, right?
No, that is not on the paper. All right, everybody listen up, guys. I've got 3 minutes. I need you to stop talking, please, and stop shuffling and just look up here. What type of transformation is this? What am I doing? What? This is a translation. On a vector, what's the vector? -1, -1. So I'm going to start here, and I'm going to move it. I need the shuffling to stop, please. So I'm going to take this shape, and I'm going to move it. It's not quite, there it is. I'm going to move it down 1 and left 1. What am I going to do with it with this? I'm going to when I multiply the x times 3, what happens to it? It stretches horizontally by 3, right? So if I started at 0 and this was 1, wouldn't it now be 3 times bigger? Right? Let's do that with the coordinate notation. So if I ended up, what is it, A prime, I'm looking at the first one, the blue one. A prime, B prime, C prime. What are my coordinates when I moved it? 1, 1. What's B? 2, 1. What's C? The 2, 1 is the C. What's B? 2, 5. Is that right? No. 1, 4. Okay, let's apply those. Let's do the red one now. If I multiply x by 3, what happens? I get what? 3, 1. Correct? And B? 3, 4. And C? 6, 1. Okay, so where would that be? Over 3 up 1. So my shape should be right here. Is that 6, 1 and what's the last one? 3, 4? Good job, guys. Yes, sir. Yeah, that's right.